Now we'll process using Myovation Evolution. So select the CT datasets.
Should we start with the Myovation only or Myovation Evolution? Or both same?
So Myovation Evolution is where all the corrections are applied. Scatter correction, attenuation correction, resolution recovery. But in Myovation you can do only attenuation correction. You cannot do scatter and resolution recovery. So
better one will be
yes,
Myovation Evolution.
right. So let's check once customization. Okay, so we'll set the transaxial pixel size 4 mm so that the slice thickness display will be 4 mm. And second change will make the scatter correction on. And then apply and quit. Now initiate it. Okay, select one day and click OK. Then perform the attenuation correction QC. Proceed. Then adjust registration. And click proceed. Similarly for the rest study. And then review tab. So these are the slices. You can see a better image quality here.
And the J software.
Right?
Yes.
And the number of slices displayed is more than EC toolbox here because we selected it 4 mm. If you put 0 there, it will display as a 6 mm slices. So this is the NC. You can see here rest IR, iterative recon, NC is non-corrected, and RR is resolution recovery. If you select AC and NC, you can see both the data sets here. So on the top series you can see IR, AC, RR, that is the iterative recon attenuation correction. So all the three types images you can see on the same screen.
Right. So
And
this
then
slice display will be there, or some data will also be included into this, like EF and all it will give, or not?
EF, yes, EF will come.
Other functions?
Yes, right. Perfusion. So before EF you can see the polar maps also. Yeah, this image. So these top two images are the attenuation corrected and resolution recovery.
Okay.
And lower image is non-corrected resolution recovery. So you can see the improvement in the inferior wall area.
Okay. So which will give numerical values?
So for numerical values you have to just right click and select the 17 or 20 segments and then click scores.
Okay.
Then you have to go to the function option here. Again, once you go to the function option, it will be always NC data, not the AC. Okay.
Okay. So the same patient, both softwares are given different EF. That software was giving 67% and it is giving 56%.
Right. So there are different. I'll show you again. So for example, save and exit this. So you will get expect saved results. So this one is filter back projection and this one is AC and this first one was NC. So if you select AC middle one and go to the AC toolbox, and go to the function directly. So EC toolbox have regression factor. I'll show you where you can select the regression factor so that it will match the EF with myometrics. In the function you have this one, EF regression factor. Here you can see higher EF, right? There was something 56 or 57. So you have to select R1, then this EF will match with the myometrics. So there it was 56 something and now it is 60. So it will be very close, within 5% deviation. So what is this regression factor is because it is third party software, so they have to match the quantitative data with different available softwares. So when it is validated, they create a regression factor. Regression factor is nothing but an algorithm which detects the diastolic volume and systolic volume of the LV. So different vendors, different algorithm they use. So here R0 is the original algorithm of the Emory toolbox software, whereas if you select R1, it is validated against the myometrics. So here the EF will almost, it may not be exact number, but within 5% deviation.
And R2 and R3 are for?
R2 and R3 is, one of them will match with the EF of QGS QPS and one of them will match with Muga.
Okay.
So for more detail, you can go to the user manual. There it is very well explained that which factor should be selected with which other software to match equal.
Okay. So this is all about the cardiac processing.
So when you are processing perfusion scan, no, always select R1 in EC toolbox.
Okay. Thank you so much.
Thank you.